Hello, this is Leanna from Period 5, and here are some easy physics problems. So, a person pulls a box across a rough surface with a steady speed of 2 meters per second. Automatically, I'm thinking steady speed is also constant speed, which means that there's no acceleration. So, the net force, the sum of all forces acting on the box, is 0. And next, the box has a mass of 20 kilograms, and the surface and box together have a coefficient of friction 1/2. Here I've drawn a diagram. So here's the person pulling the box in a, we'll call it negative direction, but it doesn't really matter right now. And here's the coefficient of friction equals 1/2. And this little K symbol, that just means sliding friction because the box is moving. And first thing I did was draw a force diagram. So here we have our normal force upwards and our weight downwards, our weight due to the gravitational field over here. And next we have friction, which is it's kind of resisting the motion of the box going in the opposite direction. And here we have, oops, I'm so sorry, this is number 2. Because if the sum of all our forces is 0, then our forces have to be equal to each other. Like friction here and tension has to be equal, and normal force and weight has to be equal, so it all adds up to 0 when you do the vector sum diagram. And so we need to find this force, the weight. And we do that by using this equation. And the 10 newtons per kilogram, that is also the, I'm pretty sure it has something to do with the gravity. So yes, this is due to the gravitational field's pull on the object. So depending on what planet you're on, you're going to have a different number here instead of 10. And so we multiply that by the mass of the object, 20 kilograms, and we get the weight of the object, which is 200 newtons. And because the sum of all our forces is 0, we know that the weight is also equal to the normal force. So we can just say equals weight equals normal force due to net force is 0. And now we need to find the friction. And we find the friction by taking the coefficient of friction and multiplying that by the normal force, which we just got, which is 200 newtons. So 1/2 200 newtons equals 100 newtons. And because the net force is 0, the friction is also equal to the tension of the person pulling the box. And I just made up a rope like Mr. Day did in class. So like we could just actually say that the person is pulling the box by a rope, and it wouldn't matter if the person was pulling the box with his bare hands or by a rope, just as long as it was with a constant speed. So anyway, the tension due to the rope is 100 newtons, same as the force of friction, 100 newtons. There we go, let's go to number 2. The box in the previous problem travels 2 meters per second faster each second, starting with a speed of 2 meters per second. So the box is already moving, but now the box has an acceleration, 2 meters per second squared. Let's see here. There's an acceleration in this direction of 2 meters per second squared. And I drew a force diagram again, and the tension due to the rope has to be longer, than the force due to friction, because the box is accelerating in this direction. In the negative direction, we'll call it negative, and to the right is positive. So we know that the normal force and the weight of the object stayed the same because the object is only moving horizontally. If it was moving vertically, then we would have some variation in the normal force and weight, but it's moving horizontally. Okay, and now that we know that, and we also know that the friction is the same because our surface didn't change from the previous problem. So all that's left is to find the tension due to the rope, because now there's an acceleration. And, okay. So if we draw a vector sum diagram, we can go beep, 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 heads to tails, remember? And here is our missing link over here. And we know this part over here is 100 newtons, but we don't know this area yet. Like, pretend this isn't there. So this is our resultant vector. And to get that, we have to use one of Newton's laws, the net force equals mass times acceleration. And here we go. The mass of the box, 20 kilograms times acceleration, 2 meters per second squared, and that equals 40 kilograms times meters over second squared, which is also the units for newtons. And so we just get 40 newtons, and that's our net force, the resultant vector. And there we go. Thanks for watching.